Hi, it's Ray from Pro Shaper Sheet Metal in Charlton, Massachusetts, and we've had a few comments on the TIG welding and a few questions and a few requests. So one of the questions was, request was to weld up a wide gap. So I've got 063 3003 aluminum with 1100 rod, 1/16. I'm going to try to weld that. I don't think I'm going to have any success. So one other, I can answer that right away. One other request was, what was my pulse setting? I'm going to be doing the tacking without pulse, but if this pulse is on right now, and the numbers are pulse time on 50, pulse amps 35, pulse frequency 3.5. That's the numbers that are relevant. So we're going to shut the pulse off and we're going to try to do those wide tacks. I suspect this is not going to work, but we'll see what happens here. It actually went pretty good. Huh. Let's go over here. Of course, I had to add rod. You can't fusion tack. So normally what I would do if I had a gap that wide, usually it gives you a little trouble, but this hasn't been too bad at all. I would put this 16 ounce copper, measures 23 thousandths thick. I would put that in there, and that would effectively close the back door and make it a lot easier to tack up. So let me put a couple more tacks. We'll try welding this and see what happens. That was about an 80 thousandths gap or so, so pretty good sized gap. Now, of course, it's pulling in because that gap is closed considerably. We'll put a couple more tacks on and then we'll run the weld. And just to try something different, I'll do this side without the pulse and this side with the pulse, and we'll see what happens.
Do you want to mark that?
Yeah. No pulse. Pulse. And this is with the Argon helium mix, 50-50. It's a lot harder running the bead with that gap there. We're going to run the back here. Now we'll do this other half with the pulse. Let's see what the difference is. That was a lot more controllable. Now let's do the back side. Smaller drop through on the back side. We'll take the pulse off for the back side. Next, we'll clean this up and then do a torture test on it and compare the two results. All right, this was the 3003 063 wide gap. This side was with pulse. This side was no pulse. We'll do the torture test. This is a beat up ball peen. It's pretty rough on the end here. That was with pulse, no break. Helium argon. This is with no pulse. That one did break. So what this does is it reaffirms that my theory that pulse and the helium argon is almost foolproof. That's a pretty good weld. That would never break in a fender situation you're welding up or whatever. But this is as strong as the parent metal. Alright, this was another request. We got the Miller, we set it 60 amps, and it was on straight argon, but I brought the Everlast deal over here where I have the argon helium tank, and I put the regulator from the Miller onto that. I purged the line out, I welded about 2 feet of bead, and it should be all purged out now. So let's, I've tacked this up. This is 063, 3003, 1100 rod, 1/16. And now we'll try this with the Miller. On this one's a very tight joint too. It was a fusion tack. That other one was a bit wide open, like 80 thousandths joint or so. It did close a little, the previous sample. It did close a little when we welded it up. Now, I did notice when we were welding that, the weld zone is just super clean. That's one of the things about the argon helium. It's just much cleaner. And we're going to just run this on the back here. So there we go. That looks very, very nice. We'll grind this up, hammer it down, and then do the stress test on it. So here we are. That's the piece done on the Miller with the helium argon combo 50/50, 063 3003 aluminum with 60 amps no pulse, no annealing. The weld bead, because it was a fusion tack on this, was much smaller than the previous one, a little less grinding, and I got it all smoothed out. I put it in the wheel, and there's no cracking or anything present. Usually if there's, after you hammer it down and wheel it, if you look really carefully, you can sometimes see a little tiny micro crack, which will turn into a split when you hammer it. I don't see anything on this. It looks pretty good. So let's give it a shot, see what we got. Looks pretty good. We hit it over on the other side. Perfect. That's with the helium argon. I've done the same weld literally hundreds of times with that miller with just straight argon, and there's no pulse on that machine, and every once in a while you'll get a crack, which is pretty frustrating. The helium argon, as you can see, no crack. I didn't do anything special. So what's the conclusion? I'll leave it up to you. I'm not a really good gas welder. I'm an adequate gas welder. I really don't have a tremendous amount of time gas welding aluminum, more so steel. I learned to gas weld steel the very first, probably when I was like 12 years old, and I did quite a bit of that. But gas welding aluminum, my actual time welding is probably less than 50 hours total. So I did get recommended to use hydrogen oxygen. I can do it with the acetylene oxygen, but I bought some hydrogen oxygen about a year ago or so, and you have to get the special hydrogen regulator. And I've got a piece of 063 here I tacked with the miller with the TIG. I'm not really good at tacking with the gas tacking, so it's a really tight joint. It's tacked. I have it fluxed up, and I'm going to put this on this little piece of angle iron here just to keep it off the bench. And I've got a 1/16 rod. I've got them immersed in the flux over here. I've got a little flux on both sides of the panel. This is the hydrogen oxygen flame. It's kind of cool. I'll show you a little demo right here. We'll put that, and you can see how fast it activates the puddle. I got it set kind of low actually, but now you see the puddle starting to form here. And what hydrogen oxygen does is it burns super clean, and it's kind of a unique phenomenon. Watch this. You can take and melt this in, make this little drip puddle here, and the coefficient of the metal or whatever will hold it together for quite a while. And it popped through there, and it's solidifying. So as I'm gas welding, I'm always looking for my foot pedal. I want gloves. I don't have gloves. I have a full helmet, and I bought a Kent White, his special gas welding lens, probably 20 years or so at least. And I have a 2.5 magnifier in here. That allows me to see pretty well. You can use a, there's a less expensive one. I did a video on that before, I think. But I'll bring I have a cobalt one that a friend gave me about 30 years ago that works pretty good. And also, I can't remember the name of the company, but we'll bring it out later. But let's give it a shot, see what we got. We'll do this with a torture test too after. I'm a little high in my chair here. I gotta lower the chair. I actually missed the seam. I can't even see the seam because of the flux on it. Flux my rod. I got really yellowy on me here. What's going on? So that's probably the first time I gas welded aluminum in like 6 months or so. So let's see what the backside. It might not be hot enough. No, didn't go all the way through. So that wasn't that successful. All right, I decided that instead of doing another sample, this one didn't go all the way through. The weld on the front side is pretty nice. Globbed it up a little bit here. I just got to get my rhythm, and I had to find where the seam was. I had trouble seeing it because the flux was covering it up. So I've fluxed the backside. If I do a test on this, it's probably going to break because it is open on the back. So I fluxed it up, and I'm going to run it on the backside with the gas again here, and then we'll grind it and test it or crush it in or whatever. It's a little Miko torch. So I check the heat. That's how fast I get the puddle. I got a scrap piece over here. That's a little hot, so. That looks like it'll do it. Away we go. So there you have it. We're totally welded up both sides. Normally you only have to do it one side. It'll usually fall through and be welded 100%. I just didn't want to weld up another sample, so I'm trying to keep the video in a reasonable amount. So we'll clean this up. You're going to have to get the flux off. You need hot water to remove that flux. A little brush and hot water comes right off. You do get a lot of flux bubbling up, and you can breathe a little bit of the fumes in and stuff. And it's actually pretty easy once you get the cadence. You have the heat right. I'll do an example with acetylene and oxygen also, and maybe we'll do another sample on another day with the acetylene oxygen and try to get the heat set so that I get full penetration. But this should work out pretty good. I think this will be a bulletproof weld just like the other ones that we just did with the TIG. So let me clean this up, and then we'll do the torture test on it. Alright, so here's the 063 gas welded with hydrogen oxygen. I did both sides because I didn't get the heat right to the first. I will do that example with the heat right at another time. So looking at this, I ground it, I planished it all in, and then English wheeled it a little bit. There's no cracks present or anything. So let's give it the torture test and see what we get. So You can see it passed the test. There's no evidence of any cracking, any fatigue. The weld looks excellent. The weld is as strong as the parent metal. There's one little fracture here, but that's probably where I had a little grinding defect, maybe. Very little. So the conclusion is, if you do your gas welding correct, it's as strong as the parent metal. If you do your TIG welding correct, it's as strong as the parent metal. You can make mistakes in gas welding. You can make mistakes in TIG welding. You got to get your techniques right, and that guarantees the results that you really want, which is strong as the parent metal. Well, I hope this TIG welding and gas welding has been very helpful. We're going to do a little bit more. We're looking for more potential scenarios. So we'll try this, try that. We'll do that. And that'll be for a later date. Please subscribe. And let's hear those comments. Thank you. It's Ray Chalene.